We are now going to display LMA and LF data. From our drop-down menu, we're going to display LMA LF charts. A pop-up menu appears that asks you to enter the number of meters per tab. The pop-up reads, select integer number of meters of data to display per page. The file opened is 26 meters long. The overview plot will automatically appear on the first page. In other words, what this pop-up is asking the user to do is enter a zoom function. So while the first page will show all 26 meters of the rope inspection, I might want to pick 5 meters per tab to do a little bit of a zoom function. So I will enter 5 and hit OK. A new pop-up appears that asks, how would you like the data to be displayed, either in a forward or reverse direction? Note that forward is highlighted, so I can move my mouse down here and simply hit Enter on my keyboard. Several of the pop-ups will have this feature. Once the plots are displayed, we can set the appropriate axis scaling here. I'm going to change the LF max from 3 to 2, the speed minimum from -1 to 0, and the speed max from 2 to 1. I'll hit OK, and then you can see the axis adjustments made here. A pop-up will appear asking if you want to accept those settings or if you want to redo and further adjust your scaling. For now, I'll hit accept again. Notice that it's highlighted, so I'll just use my keyboard enter. Referring to the log, we see that the LMA LF charts have been displayed for that file. Please note that there are multiple tabs on the figure. The first tab, which is highlighted, provides an overview of the entire rope length. Notice the 26 meters. The other tabs show the number of meters per tab previously entered. For now, we'll just focus on the Overview tab. I want to bring your attention to the upper plot, which is the LMA signal. Note that this axis is scaled and can be calibrated in terms of percentage loss of metallic cross-sectional area or percent LMA. The middle plot is the LF signal. Note that the scale of this plot is arbitrary. The LF signal is qualitative only and cannot be calibrated. Therefore, it cannot be used to determine or estimate the number of external and internal broken wires, single and in clusters, and the severity of corrosion pitting. As a consequence, it cannot be used to make rational rope retirement decisions. This has been amply demonstrated by impartial and independent round-robin testing. The lower plot is the speed signal. This signal is an estimate of the inspection speed and is calculated based on the location of the distance counters, which are spaced at 1 meter intervals, as well as the fixed sampling frequency, which is adjusted based on the level of decimation selected by the user. I can now click on the various tabs to show a zoomed-in version of the overview plot. The first area I would like to zoom in is on this 5 meter part where the LMA goes to roughly -1%. So I will select this 4 to 9 meter tab, and there is, just to the right of the 5 meter, a zoom of that signal that goes just below the -1%. I will then go back to the overview and see at roughly 10 meters this bump up to a little over 1%. So I will select 9 to 14, which is the zoom of the 10, and I can see this in a little bit more detail, and the associated LF signal shown here. First where this goes up, and then where it goes down, and the corresponding LF signal. This concludes displaying LMA LF charts.